Hello everyone, welcome back again to our channel Sarkar, and here this is Saurav live again. So I am sorry we could not come live the last Saturday because actually we had to go to a college for placement training and recruitment. Okay, so today here I am back again with our live sessions on Java. Okay, just a moment guys. So today is 6th October, I guess 6th or 5th, yeah sorry, today is 5th October, and we are again back with our Java live session, and today we will be learning some advanced OOPS concepts. Okay, so till now guys we have learnt the 4 pillars, and serially if you talk about them, we have learnt about encapsulation. Okay, then the second one we have learnt about inheritance, and we saw how we can use all the single level, multi level and multiple, but you remember right, we could not inherit multiple classes, or we could not extend multiple classes. That's why what we did, we learnt abstraction and we learnt about the concept interfaces. After that we learnt multiple inheritance, correct? 1 2 3 we learnt abstraction. Then after abstraction we got the concept of abstract classes, the abstract keyword, and then we got the idea of interfaces also. Then we came back and we learned the multiple inheritance part, right? This was done, and after that in the last Saturday we learned about the 4th pillar, which is polymorphism, right? So this was covered. I'm just giving you a recap. We have learned all these things. Now I told you that I will come live with some interesting concepts on OOPS. Those are really advanced concepts, and sometimes they are really not taught in the colleges. It's not the problem of the colleges. The agenda of their criteria or syllabus is actually to finish off some target. So they are doing that. It's absolutely perfect, no problem at all. But if you are really bothered about getting placed in any company at that time, you cannot only learn all this simple stuff and go ahead, right? You have to learn how to implement them in real life. So therefore today we will be starting with a very important concept, that is called, just a moment guys, I think, yeah, internet. Association in Java. This is a very important concept guys, otherwise, because when you actually work as a developer, say for our case Java developer, okay, you will be using the language Java. At that time, in your entire project, the project that you're building, the project, I'm talking about project, or I can say it is an application, right? In this case what will happen is you will have multiple classes and there will be so many folders and all. So I have class A, I have class B, etc., and class C. Okay, but there will be some kind of relation between these classes, right? They will be interlinked with each other in some way or the other. That concept in programming is called as association. The relation between classes in any application is known as association. Okay, that you have to understand. Please remember this guys, this is very important, and I'll trust me or not, most of the engineering college students won't have heard about this. If you have heard about this, that will be totally because you have done some extra R&D on yourself and you have done that. Okay, otherwise most of the colleges, because I've been to every college in Bangalore almost, they don't have this in their curriculum. That is the main problem. So just remember this, the relation between classes in an application, the relation between classes in an application is actually called association. Okay, so today's main topic will be this, and at the same time I promised you last Saturday that I will also show you how to use some basic Git commands so that you can understand how Git works and how actually we can integrate all our code into the GitHub online repository. Okay, those things also will learn. Fine. So just let me check if there is any comment or not, and then we'll get started. Fine. Yeah, right now there are no messages. It's okay, no problem at all. So we'll get started and gradually we'll see what interesting things we're going to learn. Okay, so I'll tell one more time. We'll be learning about association and its types, and also at the same time we'll be learning about how to use Git commands to control our code and how to actually integrate all the codes that we have written into the GitHub repository. All those things we'll learn today. Okay, that is the bonus part, because some of my audience or viewers have actually promised me, sir, please show us how to use the Git commands. Okay, that also we'll be doing today. Fine. So let's get started now. Association, as I told, it is an advanced OOPS concepts, and actually it is what? A relation between classes. So practically speaking, there are actually three types. This can be a very primary type or a basic type, and in that we have two more. Okay, the first one is called aggregation, and the second one is called composition. I will explain all these things with the help of codes. You don't have to worry about that. For the time being, I'm just giving you an idea of what it is all about. Okay, aggregation and composition. Association can be just called as a simple connection. Okay, where one class actually uses another class. Say I have a class A which uses another class B. Fine. Aggregation is what I will call it as a class A has a reference of another class B. Okay, that means class A will use an object of class B or a variable of class B, you can say. It will take a reference of class B, but they are not totally dependent on each other. But here, composition, this is very tight bounding. Okay, here I can say the class A will have an object of class B. So in other terms, sometimes association is called a using relationship, just a simple connection. Okay, but aggregation is called a loose relationship, or it is also sometimes called loose coupling. But here in composition, the A and B are actually dependent on each other. They cannot survive without each other. Therefore, it is also called tight coupling. Got it? We'll write codes, then it will be very easy for you to understand them also. For the time being, just remember these names and try to understand the meaning of them. Okay? And guys, if anyone is watching this for the first time, it is a humble request from my side. Please don't go away without subscribing to our channel, because that is the least you can do to motivate me to create more better videos for you. Okay, and those who are already subscribed and watching my videos, thanks a lot for being in touch with me, and I hope you are liking our videos. And I'm really sorry that I could not come Saturday like the last Saturday, because I had to go to a college for training and I did not get time for that. I'm really sorry for that, but I'll make sure today we'll be covering for some interesting concepts, and after that, as I said, I'll be teaching you how to send all your code or control or use a Git tool to actually track all the changes made in your code and send them to the GitHub repository. That will be our target. Fine. So let's do it. So now, this is a little bit confusing, right? Let's do one thing to understand that. In aggregation, let me give a idea like this. Say you have a car and the MP3 player. In case of composition, say you have the car and the engine. Just think, you will understand that. I will ask you a question now that will give you a clear idea of what I am talking about. Okay? Just listen to my question first of all. Can I take out the music player from the car and use it in my classroom? Can I take out the music player from the car and use it in my classroom? Absolutely yes, provided I have a power point. I have a plug point where I can plug in the plug of the music player. That's it, right? That means the MP3 player is not dependent on the car, or the car is not dependent on the MP3 player, right? They are totally different classes and objects. This is why it is called loose coupling. Understood? Similar way, car and the engine. Can I take out the engine from the car and use it in my classroom? Not possible. The engine is dependent on the car. Similarly, if I take out the engine from the car cannot survive, right? We cannot drive the car. It's impossible. So they are totally dependent on each other. Make sense? That is why it is called tight coupling. When the objects of different classes are not totally dependent on each other, it is called loose coupling or aggregation. When the objects of two different classes are absolutely dependent on each other, it is called tight coupling. And these are actually parts of association, which is what? The relation between classes in a project or application. Make sense? So please remember that. Hope you understood the idea. Now let's take certain examples so that we can even understand this in a better way. Okay, I will take 3 simple examples so that you can understand this and never forget this in your life. I can challenge you on that. Okay, and again at the same time I'm asking you guys, if you are watching this for the first time, please subscribe to our channel Coders Arcade and help us reach 50k subscribers soon. We are already 48.7k on and going. Let's help us to reach 50k soon, guys. Please, that's a request from us. Okay, so let's get started with our today's coding sessions. Fine. And any doubts in the middle of the session, feel free to ask them. Okay, don't hesitate to ask even a small doubt. I am here to help you out. Trust me on this, guys. Okay, so let's get started and write down the codes. The first one, I'll show you a simple example of association. Fine, let's do it. I have renamed my project to Java YouTube live sessions. You can see there, and earlier we had already done the OOPS concepts. You can see all the pillars we had discussed, correct? And now in this, what I will do, I will create a new package called association. Fine. So right click, new package called association. Fine. And then right click, new Java class, I will say association example. Okay, so let's try to understand how it is working. I will take a class called driver, and I will take a variable, string, variable or attribute, you can say, name. Okay, let's take the constructor, and here I am trying to initialize the name of the driver. Okay, just like that, very simple example. I'll say this dot name is equal to name. Fine, and then I will take one more class called car. Here I will take a string variable called model, and after that what I will do, just see, I will take the car class constructor and say string model. Here I will write this dot model is equal to model. Fine. So I'll repeat. I have a class called driver. It can be any random driver, whoever drives the car. Okay. I'm taking the name of the driver and then the constructor to initialize the parameter or the attribute. Similarly, I've taken a car class where I have the model of the car and I'm taking the car class constructor, and then what I'm doing, I'm initializing the constructor with this model name, whatever name it is. And now inside this car class, I will take a method void assign driver, and just see what I am doing now. I am taking a driver instance from this class. Okay, remember this, I have not whatsoever used the new keyword here, right? Now what I will do, I'll say s out. I want to print something like this. The driver drives the car, particular car. Okay, so here I will say model, or I can say driver dot name plus drives the plus model. Okay, understood what I have done? I have taken an assign driver method and I have said driver dot name, whoever it is, say Saurav, John, anything, it can be anything, drives the model, whatever model name I will give, it will be printed. Now let's go to this one and say main function. I'll create the driver object, driver is equal to new driver, and what is it asking? It is asking me the name. So I'll say anything, say what? Charles. Fine. And then let's create the car object. Car is equal to new car. What is it asking? It is asking me the model number. Say I am saying Tesla. Fine. And then in the car class, you can see that I have a method called assign driver. So let's use that. I will say car dot assign driver, sorry, not model, assign driver. And what is it asking? Can you see? It is asking me for the, if I again give the bracket, it is asking me for the driver. Okay, so I will just pass the driver instance here. Fine. Now the output should be Charles drives the Tesla. Let me run this. See guys, Charles drives the Tesla. What does it mean? What does it mean? In this example that we have taken, what is happening? This is a very independent class called driver, and this is also an independent class called car. In that, what I have done is, I am just simply taking a method called assign driver where I am just using this driver instance. Okay, I am just using. So I am just connecting them. There is no, what to say, no relation like coupling in this case. In this case, there is just using relationship that I showed you here. You can see here, I said that A uses B. In this case, our car is actually using the driver, that's all. And they are totally independent of each other. They are not related to each other. There is just use relationship. Okay, got it? Therefore, when I am printing this car.assign driver, it is just asking me for the instance. They are not dependent on each other. The relationship use. So, car uses driver, that's all. Or you can say the alternate way also. The driver uses the car. He is driving the car. As simple as that. This is a basic example of association where you can simply relate two different classes like this. Now, let's talk about the other one, which is what? Aggregation, and it is called loose coupling. Let's see a simple example to understand that also. So here, let's create a new package called composition, and here let's create a new Java class called composition example. Okay, this I will keep intact, and at the same time let's create a new package called aggregation. Inside that, let's create a new Java class called aggregation example. Fine. So let's start with this one, the first one, aggregation example. Okay. Now, first thing first, let's create a class called library. Fine. And let's create one more class called student. Remember, we are learning aggregation, loose coupling. So here I am taking a string name of the library, and then I am creating the constructor of the library and saying string name, and then I am saying this dot name is equal to name. As simple as that. No worries about this, right? I cannot see any doubts till now. So I hope everything is okay till now. No problem at all. After that, let's go to the student class and say string name, and guys, watch what I am doing now. I said in aggregation A references B, or it takes a reference from B. Okay, so in this case what I will do is, in the student class, student will refer some library. I as a student go to some library, right? That is what I am trying to do here. So I will take a library reference. Understood? I am not creating an object, I am creating a variable inside that. So I am referring this from here like this. Now, what I will do is, I will take the constructor. Guys, remember, the constructor can be public also or default also. In our case, I am just writing default, okay. So student bracket, I'll just say string name and library. Make sense? And then see what I am trying to do here. This dot name is equal to name. This dot library is equal to library. Okay, and now what I am doing, see, I'll say void display student I'll just say that something like this s out name plus I'll say uses or studies in space plus library dot name. Okay, got it? So I have this function or method here which is doing this. Fine. Now let's go to the class that we created for the main method. Here what I will do, I will create the library object, library. Fine. Here what I am doing, I am taking the name of the library, say central library, and I am creating the student object. Here I am say writing Saurav. See, now try to understand this. When I am writing the name, it's not accepting that because in the constructor I need to pass the library also. So I am passing library. Now it's working, and then I'll just say student dot display student. Let's see the output. It should say Saurav uses or studies in central library. Got it? So what I did in this case, I used a reference of the library class in my student class like this. I use this as a variable or a parameter. Got it? That is how it is working. And you can see in this I have a method called display student where I am printing the name and studies in what library. Now the point is, just try to understand how it is a loose coupling. I will tell you. We took the example of what? Library, right? Library. And here I have taken a student called Saurav. Okay? Saurav is using that library. But is the library dependent on the student? No, right? Got it? The library is not dependent on a student. That's why it is called a loose coupling. So it is called a has a relationship. Got it? Library has a student. It can have multiple students. So that is how it is loose coupling. Because I am only using the reference of the library in the student class. So the library is absolutely not dependent on a student. It can have any kind of student. Even if I delete the student class, the library class will not be affected. Got it? So this is called loose coupling. When the objects of two classes are loosely dependent on each other, it is called loose coupling. Understood? This is how aggregation works. Now let's go to the last one, which is called composition. Guys, any doubts, anything if you have? I'm not getting any comments, so I feel everything is fine. If you have any doubts, let me know. Okay? So let's go to the composition example and take the same example that we had taken earlier, the car and the engine. Okay? So here I will take a class called engine. Okay? And here what I will do is I will take string engine type. Okay? And let's take the constructor engine. In the bracket, let's take the engine type and assign it here. This dot engine type is equal to engine type. Fine. Very simple example that I am trying to take. Fine. In the engine, I am taking the type. Say Tesla is an electric car, something like that. Type electric for petrol, diesel, whatever it is. After that, let's take a void display type, and here I'll just say S out engine type plus type. Okay, sorry, engine type. Fine. So what I'm doing, I'm taking an engine class where I have a parameter or attribute called engine type, and then I am taking the constructor where I am initializing this attribute by taking this this dot engine type equal to engine type. After that, I have taken one function called display type or a method where I am just printing the engine type. That's all. Very simple. Now, let's go. Okay, I have not seen any comments as of now, so everything is fine. Let's go to our class car and then just see what I am doing now. I am taking string name of the car, and then string, or let me take engine. Okay. So this time I am creating a reference for the engine class. Fine. Now see what I am doing. Try to observe this carefully, guys. Otherwise you will not understand. Now in the constructor of the car, I am taking string name, comma, string engine type. See what I have done. I have taken the string name and taken the string engine type. Engine type is here. Try to understand what I am doing, okay? I will show you how it is type coupling. So, I will say this dot name is equal to name. That's absolutely fine, right? And then see what I am doing. I am saying this dot engine is equal to, now this is actually an object of that class, right? Now just see what I am doing. I will use new and create an object of the engine, but remember, what does this engine object take as a constructor argument? It takes the type of the engine. Here I will pass this engine type. So what happened? Object created, that means this car engine is totally dependent on this particular class engine, because I have created an object by using the new keyword here. In the earlier case, aggregation example, that was not the case. I have just used a reference here. See, I have just used the reference of the library. That's all. Correct? But in this one, in the composition example, if you see carefully, this I have this dot engine, this particular attribute is actually a new object of the engine class. That is how it is tightly coupled. Got it? So now let's do one thing. In the car class, I will say void what can we write? We can say details. Okay, and then in the details, or let me say car details, s out, what was that? The first thing, name of the car, right? Name plus, I'll say car name plus name, fine. And then we need the engine type. So I'll just take this engine variable here, the object engine dot engine type. Okay, not like this. There was a function called show type or display type, I guess. Yeah, this is the one. Fine, got it? Now let's go back here in this one, and in the main method, let's create the engine class object. Engine is equal to new, or we can do one thing. Now by using the car class only, you can do everything like this. I'm saying car is equal to new car. Now see what are the things that it is asking. It is asking me the string name and the engine type. Say I am writing Tesla, and the type of the car is, say, electric. Okay, ELECTRIC, sorry. Got it? Tesla electric. Now let me just say car dot car details. See the output now. car name is Tesla and the engine type is electric. Got it? So I will repeat this again. Yeah, learning says, can we achieve same concept with interfaces like loose coupling and tight coupling? Absolutely, we can do this, but most of the time it is done using classes, okay, learning. It can be done using interfaces, but interface is already a totally different kind of concept. We don't use that to couple things. It becomes a little bit complicated because again you have to do the implementation in the child classes, right? You know that, right? Interfaces methods are empty. So again you can do it, but the thing is that if you are okay with the complication of the code, you can absolutely do it. But if you are not okay with the complexity of the code, then I suggest you don't do it. But absolutely you can do it. There is no harm in doing that. If you are really good in writing the code, then you can absolutely do it. No problem at all. Okay. And now, so I hope now you have understood the concept, right? See, the car is actually dependent on this engine, otherwise it cannot survive. So whenever you are creating an object or instantiating an object of any other class inside some other class, it is called composition or tight coupling, because you have created an object. Okay, so it is totally dependent. But in this case, the other one, the library is not dependent on that one. But in the last case that we saw, it is absolutely dependent on the other one. Got it? That is how it is. And you see here, you'll understand that. As I said, car and engine, it is tight coupling. And what did I say? You will have an object of the class in the other class. See? So if I repeat them, just try to understand. A uses B. That is simple association. You are associating the classes. Okay? There is no parent-child relationship. Nothing like that. A uses B. That's all. Okay? The second one, loose. I am taking a variable of the other class. That's all. Reference. The third one, I am creating an object of another class in my class. That is why it is tight coupling or composition. I hope now you have understood it perfectly. If you have any other doubts, you can tell me. Sir, we can have default method inside interface. Interface default method. What default method are you talking about? I did not understand that. The point is that interfaces have methods and you don't even have to write public or private. See, what I am saying is, in case suppose you are writing an interface, suppose you are writing an interface here, learning, and having say anything, say learning only, I am writing your name only, fine. I am creating an interface. Here you were saying default methods. Are you talking about the access modifier? So normally we don't write that, right? So if I say learning, this is the method name. You can see here, what does it say? Invalid method declaration, return type required. Okay, fine, that is okay. I can write int learning, doesn't matter. And we have to leave it like this, correct? This access modifier is invalid. See here, it doesn't matter because the implementation has to be given in the child class, right? That is why it is not written like this. By default, we leave it blank and it is absolutely fine, no problem at all. You don't have to write public, private or protected. It's meaningless because how will you implement that in the child class, correct? You see here, private methods in interface should have a body. Then see here, suppose I am writing s out, code is Sarkar, and it is returning an integer, right? Let me return 0. Got it? I hope now you have understood this concept. If a method is private to a class or an interface, that is absolutely accessible inside the class only for those kind of objects. Got it? Guys, that is a totally different concept which will be coming under types of interfaces when we learn them. Okay? There are marker interfaces, there are SAM interfaces, single abstract method interfaces, those kind of things will come there. Okay? When we will be learning them, at that time we will be definitely learning about all those things. So for the time being, just remember that normal default, if you don't write anything, they will become something like this. Okay, say I'm writing int Saurav, just for example, I'm writing my name only, and then you cannot have the body of that. Okay, if it is private, then you have to give the body of that, because that will not be implemented in the child classes. That will be done here only. You know about the private access modifier, right? That is how it works. Make sense? So for the time being, let me just comment this part. This is not relevant to our code, or let me just cut this, delete this one here. Okay, fine. Hope you have understood this now. Okay. Any other doubts, guys? I told you, right? Any silly doubt, any interesting doubt, any very complex doubt, feel free to ask. When you ask, when you solve them, when you write them down in front of you, then only you will understand. People can say, can we do this? Can we do that? Try doing that. Nothing will happen. What can happen? The max, this code can get some errors. That's all, right? Errors can be fixed. But that is how we learn. Understood that? So I hope now you have a clear picture of aggregation, composition, and as a whole association. If you have any doubts, feel free to ask them. Now, how many of you want me to give a demo on Git? Because that is my plan today. I need some comments and some response from the audience. Then only I will start with that. Otherwise, we have basically understood all the OOPS pillars, the advanced concepts, the basic concepts, and many other things. Okay. So if you really need them, just let me know, then we will go ahead with that. Because that is my plan, and even if nobody is saying yes also, then only I will go ahead with it. Obviously, I will have to go ahead with it, but at the same time, I need some motivation so that I can go on with a separate concept which is totally out of context in this OOPS concepts. It is not OOPS. I want to give you a demo on Git and GitHub and how to really use them day in and day out. Okay. So if you are really ready for that, you can tell me. What we will do is, my target is that I have this project, Java YouTube live sessions. That's what I want to load into my GitHub repository. How to do that and how to actually know about the Git commands. That is my target. Okay. Yeah, I'm waiting, guys. Let's hear from, yeah. Yes, sir, we need demo. At least learning is saying something. So fine, let's do it. No problem at all. What we will do? We will leave this project like this only. We will not touch it right now. I'll go back to my whiteboard and let's try to understand that. Okay, guys, if you have anybody who is really willing to learn about Git and GitHub, and most importantly about this concept called version control, then you are at the right place, and I can guarantee you that after this you will be really understanding about version control, and also at the same time you will understanding about how to use Git and how to use GitHub. Because in interviews you should have a very strong GitHub profile. Not just copy pasting the code in GitHub will help you. You have to understand how in and out everything works. Fine. So let's do it. Let's try to understand what it is. Okay. So I'll start from scratch. So it's going to be a little bit interesting also. So as a developer, my company will give me a laptop, or maybe I have my personal laptop, doesn't matter. It will be always called my local system. This keywords you will be hearing a lot, okay? Local system, your own system. Fine. Here, you are trying to build an application, app. That application will be actually inside what? It will be inside a folder. Guys, here is an opportunity for you guys. If someone wants to really learn about this cycle, the software development life cycle, and how it is actually used in DevOps, here is your chance. You can tell your friends to join this live link. Okay. So as I said, when you are actually building an application for a client or for yourself, you are writing it inside a folder, fine. And then at the time, this folder, what will you do? You will create files. What kind of files? Say index.html, say it is script.js, style.css, data.db, it can be login.java, right? There can be multiple files, right? You can have that. Now, when you are actually working on your local system, now remember this, people really confuse between these two keywords, Git and GitHub. Git is actually a tool, a version control tool, with the help of which you can track changes in the code that you have written. Okay, because in the industry, say suppose learning, suppose someone called Pavan, someone called Kumar, someone called Saurav, all of them will be working in a team, and you should actually know who is making the changes to your code. That is very important for you to understand. Okay, in that case, when you are working locally, nobody is tracking your changes. So, what you do? Use a version control tool. So, till here, whatever you have written, say suppose you have written lots of code here in the index.html file, in the script.js, in the style.css, and the data.db, login.java, say file.c, whatever it is, all the files that you have created is for application. Fine. This area, this whole area is called remember this, untracked. Nobody, no tool is tracking them. Git is not tracking them. Okay, it is untracked. Now, first thing first, if you want them to be tracked, so that many people can ask you, what is version control? Simple thing. Let me just say Windows and say paint. Here, I have written something randomly, and then by mistake I deleted that. Can you get back? Can you get back the data that I had? Whatever it is, it was a file, it was a code, it was a line. 1 second, guys. Just a moment. Just a moment, guys. There is some disturbance, so just wait for it. Okay, yeah, I think I am back. Sorry for that. Actually, the camera got heated up and I lost the connection. Fine. So, what I was talking about is, I'm talking about that all the files that you have written, and I showed you something. I had deleted something from my paint folder, right? If you delete something by mistake, or if you change something, and if you don't track them, it is very difficult to get back to that position. Okay, that's why we need a we need a version control tool to track the changes made in our code, okay, so that every time we can have a, repeat this word, we can have a stable and working code. Stable working code, that is very, very important, okay. So in that case, I will create a local repository, okay, local repository. How? By using a command called git init. Fine, git init, and then it will initialize an empty repo, okay, it will be empty in the beginning. After that, it will tell you that you have to add these files from the untracked area to this area. How will you do that? There is a command called git add. Either you can write file name dot extension, or if you want to add all of them together, you can say git add dot, which will add all the files. Remember, I'll repeat, this is for all files. Make sense? Now all your files are being tracked by Git. Even if you lose something, you can again get back. That is the benefit of using Git, okay. You will always track the changes made to your code, to your application. That is the best implementation of Git, okay. That's why it is called a version control tool, okay. And what is GitHub? GitHub is what? GitHub is actually a cloud storage, nothing else. It is a cloud storage where you can store the codes that you have written. The stable version of your code should be always stored in GitHub, okay. Now as soon as you use git add dot, this area becomes the staging area, and all your codes that you have written are now tracked. Fine, all your codes that you have written are now tracked. Tracked by whom? Tracked by Git. Now you will not lose anything. Got it? So now after that, you were having lots of random files. You added them to the initialized repository. After that, what you did? Now you are sure that, okay, fine, I have written some amount of code that is absolutely fine and working. Now I need to finalize that or commit that. For that I have a command. Here, let me delete this part. Now after I have finalized that, whatever code I have here is fine, is working. I will commit my changes. So the command is git commit, okay, with some particular message. So I will write -m, this is for a flag, and here into double quotes I will write a particular message, okay. Got it? Now Git knows that, or say, suppose as I said, the whole team, there are so many users, all of them will know that what changes you committed and what you actually did, because otherwise people can not understand, it will be ambiguous who made the changes. That's why while committing, make sure you give the flag M and give the message. Now what happens when you have committed? This is something final, this is working and it is final, okay. So it will save this as a snapshot. Point is where in your project there will be a folder called .git. Here your whole code will be saved as a snapshot. So every time you commit some changes, it will have a snapshot. Got it? That is how Git tracks all your changes. And now, if you really are feeling difficult to understand this, and if it is really intuitive, at that time what you can do is remember something like this. I will take a simple example to tell you about this. Try to understand. A guy who is looking for marriage. Looking for marriage. At the time, what it does? He has a large pool of prospects. Say girl 1, girl 2, girl 3 and n. Multiple. Lots of prospects. Because he has just started his journey. He is looking for a girl to marry. Okay? Lots of prospects. After that, what happens? This is the untracked stage. You have lots of options. After that, here I am writing some code and finding that it is fine. So here the guy has say 4 options: G1, G2, G3, G4. Fine. So out of the large pool, the guy now has only 4 left. Got it? Now out of this 4, this guy will finalize only 1. Got it? So here this guy, say suppose this guy is finalizing the girl 3. Okay? So this is our guy and he has finalized our girl 3. It is a commitment, engagement. Make sense? This is how it works. If you really understand this way, you will also understand this the other way also. Got it? That is the stages. Untracked to staging area to commit. Got it? Where we get a snapshot. Hope this is understood. Got it? That is how the best you can explain this in the interviews also. If you see it this way, the interviewer will even understand in a better way. You have lots of choices because you are doing lots of changes in the application. After that, you have finalized some of them and finally you have one stable version of the code, which is this one. Make sense? That is how Git works. Now let's do one thing. We will add all the files that we have created till now into our GitHub repository. Fine, let's do it now. So I'll go back here and you can see here, right click, open in Explorer, and this is my folder. Right click, I'll say show more options. You can see one option there called Git bash. Git bash. I'll click on this. Fine. See, at that exact folder I have opened Git bash. Git bash is the Git terminal which gives you a feel of the Linux version of the terminal. Okay. Now what we will do is we will say git status. I will show you some basic commands which will be helpful for you in your day-to-day life. Okay. Git status. Right now I have not initialized any repository. Make sure you remember that. Okay. So it will say fatal, it is not a Git repository. See, not a Git repository. Got it? So the first command that I showed you here was git init or initialize. So let's do it. I'll say git init. As I said, it will initialize an empty Git repository in that particular folder. Okay. So if you go here, I said it will create an empty Git repository. Fine. After that, let's check the status now. It will say untracked files. I told you, right? Now Git is not tracking anything. Untracked files. All these files that we have now are untracked. Now we can lose them. So what we do? I'll say clear. Now I'll say git add individual files also you can add. Otherwise I can add a dot. All the files will be added. See, let me just say again, git add dot. It added everything. Now let's check the status. You can press the up arrow and the down arrow to to swap between the commands that we are using. Now you can see all the files are green now. Earlier if you see, they were all red color, right? So now all the files have been added here. Now let me say clear again, and then let me check the status now. Everything is fine. All things are green. Now after that, now they have come to the staging area. That's why I took this green color. Now I am sure till now whatever you have learned, we will commit the changes, okay, with the git commit message. So I will say clear. Once again, clear is the command to clear the screen, okay, nothing else. I'll say git commit minus m. Minus m was the flag, right? I have showed you here, see, minus m. Git commit minus m with some particular message. So I will say added all the working codes, sorry, till 5th October working, let me say Java codes. Fine, and I will press enter. No errors. Now let me clear and let's see the status again. On branch master, nothing to comment, the working tree is clean. Now this is a new term, right? Master. What is that? Let's try to understand that. So now we have a snapshot of our code and everything is saved. Now what I'll do, I'll just try to say something here. Just try to understand this, okay? Whenever we are actually working the code, we will be in the main branch or the master branch. Okay, this will be our main branch where we will not be making any changes. The master branch does not have any changes. Okay, so suppose Saurav is a developer and he wants to make some changes. So what he will do, he will create a new branch. Say I want to add some feature. So I am checking out with a new branch, making my changes and then again merging them into the main. Got it? That is how it works. So master on the main branch will only have the stable working code. Nothing else. It will only have the stable working code which will be actually deployed later into the server or the cloud. And anybody else, say suppose learning is one more developer, L1, he wants to do some changes. So he will again check out with a branch called L1, L, and then again after that he will merge his changes here. Got it? So every time you can see the master or the main branch has only the stable working code. When we are sure that all the code in our branches are clear or okay, then only we will merge. But this will be done by your manager. You will not have access to this in the beginning. As a fresher or maybe 1-2 years experience, you might not have that. Okay. So this is how the actual tree works. That's why it is called a working tree. Got it? You saw this thing here. Check. On branch master, nothing to commit, working tree clean. That means right now, here, we are somewhere here. Working tree is clean. So it has the stable version of the code. That is how it works. Now, till now we are in our local only. We have not added anything to GitHub, right? Now let's go to GitHub and do the same thing. You guys are understanding this, right? If you have anything else, you can tell me in the comment section, guys. I'll be very happy to clarify them. But this is actually how Git and GitHub works. Now we have used Git to control all our codes or track all our codes. Now I will do one thing. I will go to my GitHub repository and then I will create a new repository for you guys and then I will add all the codes to GitHub. Okay. This is my GitHub repo and then let me create a new repo. Okay, I think there should be a dark mode. Let me check. Do you have a dark mode here by chance? Otherwise, settings, appearance. Okay, dark. Yeah, this is the dark mode. Okay, let's go back here. Fine. So the dark mode is otherwise, it is otherwise not visible to you guys. So I am making it dark. Fine. So now there are lots of repositories in my GitHub. So I'll create one more. I'll go to my overview and go to repo, this part, and here what I will do, this is the button you can see, right, for creating a new repository. I'll click on new, and then Saurav Nath says, what is OOPS in simple in any programming language? Object oriented programming is actually a concept. It is not some programming language. Very good. Object oriented programming is actually a paradigm or concept, okay, where we can actually implement real world things in a very easy and efficient manner. Say suppose I am talking about a class of students. So that class will be called student, and all the students, say learning, someone called Saurav, someone called Tanmay, someone called Ujjwal, etc., etc. All those people will be called the objects of that class. So object oriented programming is a paradigm or concept which helps us to write better code and in a more efficient manner. That is what is called object oriented programming. And guys, if you have not watched our previous videos, and I am talking to Saurav Nath also, and by the way, my name is also Saurav, okay. So I am telling that you can go on to the description of this video when it will be uploaded live. After this live session ends, it will be uploaded again to the YouTube channel, on our YouTube channel, okay. At that time, you can go ahead and see the playlist. There are dedicated curated videos on OOPS concepts, okay. You can learn from there. Fine. You will get a better understanding, because in a simple word I cannot say everything about OOPS concepts. You have to learn, and then only you will understand. Fine. So now let's create this repository. I will say what? YouTube live Java. Fine. YouTube live Java I have written, and here I will say this repo is for the live YouTube sessions on Java basics plus DSA. I'll say advanced plus DSA. Okay, just for a description I am writing like this. Okay, you can skip this part. Fine. This is the name of the repository, and then I have written a description like this. This repo is for the live YouTube sessions on Java basics plus advanced plus DSA. Fine. And guys, if you are working in a team, you can keep it private and send the access tokens to the people, or else right now I'll keep this public so that everyone can access it. Fine. And then just you have to go down here and click on create repository. Fine. So it is actually creating the repository. Let's wait for a moment. Yeah, it's created, and it is always good to have a readme.md. See here, it is always good to have a readme.md which actually shows what this repository is all about. I will do that later. For the time being, what is my interest is this part. See here, this is actually the URL of this repository. Okay, this one, github.com Saurav Sarkar /Sarkar YouTube live.git. This is the URL. Okay, so what I will do, I'll just copy this from here, go back to my GitHub git bash. Fine. Now what I want to do is I want to connect this local to the remote. GitHub is remote, this is my local. And if you want to see here, you will see that there is nothing in this. This is totally empty, completely blank. See, it is nothing there. We'll go back here and say git remote add origin. This commands you can learn from the official GitHub website, or gradually when you keep on doing it, you will learn it again and again. Okay, and because I copied the URL, I'll just paste it here. Okay, now I'll say press enter. Guys, if you're doing this for the first time, you might have to configure your GitHub account. Okay, the username and the password you have to give, but normally it is not required because I have already done this. Now let me just say git status. Everything is here fine here. Now I want to push all my code from my local to the remote. So let me clear this and git push -u. I am updating with a flag. For the first time when I am doing, I am just using the update flag. Okay, git push -u origin, and which branch am I trying to push? My branch name is master. If it is main, make sure you write the correct branch name. I am saying master. Press enter. See, all the things have been sent to the master. Let's go back and verify there. Right now also, if you see, it is empty, right? Let's refresh this and see the magic. See guys, you remember the commit message that we had written? Added all the working Java codes till 5th October. Let's go back here and see the same thing, okay? So you can see git log minus one line. See this? This is giving you a number, and this number is what? This number will help you to go back to that version where you had written something. Okay, suppose you are committing once again, you can go back to this particular version. Okay, and see the message. Added all the working Java codes till 5th October. This message is here reflecting in the GitHub repository. You can see, right? Okay, so now see the magic. All the files in the source folder. See, if I go to oops, whatever we have learned today, say go to association, and if I go to association example, we learnt about the driver and the engine class. Remember, driver and the car class. See, this is the code. See, isn't it good? Isn't it awesome? We have actually pushed all the code that were written to the online GitHub repository. Okay, and guys, I will do one thing. I will share all this code, or I will share this GitHub link in my description only, so that you also can get access to it. Don't worry about it. And guys, please give this video a thumbs up if you have really learned something about GitHub and also about association, aggregation and composition. Fine. And I hope you really like this lecture. And if you really like this lecture, guys, you know what you have to do. Hit the subscribe button, guys. Please subscribe to the channel, and at the same time, the notification bell is a must, because that will help you to get updates about the latest videos, the latest content that we push in our channel. I will talk about push and pull because we have learnt about Git right now, and it is really amazing. And if you have any doubts, if you have not watched this live video, this will be again uploaded in our YouTube channel as a recorded video. Okay, you can do that and comment your messages. I will be very happy to reply back to all your doubts. And thank you for watching, guys. This is Saurav signing off. Once again, next Saturday we will come back